Hello. In this video, I will show you how to configure basic parameters and create a PLC logic to run spindles in CNC machine controlled by Bosch Rexroth MTX control. It is a part of series of technical videos showing functionality of MTX controller, and all those videos are available on YouTube under Electric Drives and Controls, CNC Controller MTX. This presentation is a continuation of video CNC MTX, Axis Setup and Monitoring. So again, we'll use a latest version of IndraWorks Engineering software and open our project from previous video called MTX Initial PLC Channel 1 Axis. We will again keep this project untouched and then create and work with a copy MTX Initial PLC Channel 1 Axis Spindle 1. First, we'll go online, then NC configuration, and here we can edit basic NC configuration still active in our control and used in our previous video. In this exercise, we'll not need axis 5, so we'll remove it. Axis 4 is already configured as virtual spindle with spindle index 1 and circus address 4. Next, we'll go to basic parameters and then spindles. Here we'll add additional parameters related to our spindle. Our control provides detailed description of all parameters with built-in help file. And to activate it, all we need to do is to click on Information tab. So first is a selection of spindle type. We can see that there are 5 spindle types available, and depending on the type, they can be controlled by NC kernel or PLC. And in our exercise, we'll make it a circle spindle. We can also assign a name to the spindle or leave it empty, and system will automatically identify it as SSP01. Next is gear selection. We can have up to 4 gear ranges for every spindle and 2 gear change methods. Since we'll use circle spindle and all gear functionality is handled by the drive, we'll leave only 1 gear range and method type drive. Next, we must set maximum speed and acceleration for every gear, and for now we'll leave default values for speed at 6000 RPM and for acceleration at 100 radians per second square. Next is spindle override, and here first is a maximum for this override, and we'll leave it at default 120%. Next are override steps, and here are 2 methods of selecting override value. First is a table with up to 32 elements containing percentage values for every step. So for example, value 65% is assigned to stage element 5. And to set spindle override to 65%, we need to write value 5 to a special override signal in the PLC. This method is very effective when we use multi-position selector switch. To use continuous potentiometer or HMI slider, we can set all step values to 0, and then in a PLC, write a value of override directly to interface signal with scaling of 0.01%. Next are speed windows for speed reached and spindle standstill, and for now we will leave them at default values. Next is spindle jog. Here we can see that there are 8 spindle jog speeds available, selected via PLC. Without selection, by default, first speed is active and it is set to 0. So we'll set it to value 100. Next is a turret function, and we'll leave it as no. And for now, we will not allow the spindle to be controlled by more than one channel. Next is spindle command syntax. Here we can see a list of all commands for spindle 1. If you have more than one spindle, here are commands for spindle 2 and all additional spindles. If there's a group of spindles created, and we can have up to 4 of those groups, here is a command list for all spindles in the group. Next, we'll work on spindle administration. All system spindles are assigned in a spindle management to be channel spindles, or in a compatibility mode with older systems as a group spindles. In channel spindle mode, up to 8 spindles can be assigned to one channel. In spindle group mode, first 8 spindles can be distributed over up to 4 groups, and they can be called from any channel. So in our case, we'll use default method with spindle groups, where our axis 4, which is a system spindle 1, will be assigned to channel 1 as spindle 1, and also assigned to group 1. To do that, we need to go to Context menu SP, and here assign the spindle 1 to group 1. If we want to use channel spindle method, we need to change Context menu to channel spindle mode. So first, we must right-click on spindle administration, then modify info, and then channel spindle. Here we can select channel 1 and assign to it system spindle 1. Last parameters to be configured for spindles is block switching control. We can enable different weighting conditions in connection with spindle functions. These conditions delay the start of path movements of an NC block, and for now we'll leave them at default values. Next, for all those parameters to take effect, we must restart our system. After control restart, we'll work on a PLC logic to control our spindle. First, we need to inform our PLC of our spindles and create an interface signals for them. So we click on MTX NC PLC Interface tab, then Spindle Interfaces, then Add, Device, and then Spindle Interface. New tab, Spindle Interface 01, shows up, and after we click on it, under tab Spindle Interface Objects, we can see 2 variables, Spindle Interface 01 in and Spindle Interface 01 out, automatically created for us. Those variables are a dedicated structures type MT-ISP type and MT-QSP type. Those types are part of standard library MT-base, automatically added to the project, and we can find their definitions under Data Types, then NC PLC Interface, then MT-ISP Inputs, and MT-QSP Outputs. More information about interface signals in those variables can be found in Help file under System MTX, then MTX PLC Interface, and then spindle-related interface signals. Here, when we click on Overview on Output Signals and see all available commands and outputs. For example, jog plus and minus, spindle reset, start and stop in manual mode, spindle speed override, and drive enable. There is also a list of all inputs, for example, status and direction of rotation command, or drive power on and operation status. When we click on Signal Description tab, we'll get additional detailed information about any of those signals. For example, spindle reset or spindle manual turn command. Back in our project, so first we'll add a new program dedicated to spindle operation. We'll name it prSpindle and select ladder logic as implementation language. Next, we can click on this new program and add our logic. First, we must be able to reset our spindle. So in our first rung, we'll insert new coil and then assign to it proper spindle interface output. We know from previous videos that the easiest way is to use built-in smart coding function. So we just start typing a name of our variable and system will give us a list of available variables. Next, we pick our structure spindle interface 01 out. Next, we can edit our variable, and to select a sub-element, we just type dot, then the new list shows up, and here we'll pick up a sub-element QSP reset. To operate our spindle, same like in previous videos, we'll use IndraWorks Operation panel. And to reset spindle, we use the push button error reset. This push button controls a global variable PB reset, and this is a variable we'll use in our logic. All variables for our operation panel are located in global variable list GVL HMI. Here we have all variables for push buttons, all variables for lights, and other variables used by HMI. So we must add new variables for spindle operation. Here is feed rate override type word, so we'll add variable SOVRD, spindle override, also type word. Next, in the push button group, we'll add PBM03, a push button to start spindle clockwise, PBM04, a push button to start spindle counterclockwise, and PBM05, a push button to stop spindle. Additionally, to select spindle for jogging, we'll make a push button PB select S. Next, we'll add some lights. So here are LTM03, LTM04, and LTM05 to indicate if spindle is running clockwise, counterclockwise, or is stopped, and light LT select S to indicate that spindle is selected for jogging. Back in our program prSpindle, next rung will be for spindle override. And since we use a direct method, we must scale it to 0.01%. So we'll insert new box and make it type multiplier. Use it to multiply our HMI signal SOVRD by 100, and then write a result to spindle interface output QSP override. In the next rung, we'll make a logic to start our spindle to run clockwise. So first, our coil, and it is spindle interface output QSP turn clockwise. This output will be activated by push button PB M03, and it should be allowed only in manual mode, so we add a contact LT manual to verify it. In the next rung, we'll make a logic to start our spindle to run counterclockwise. So here our output is spindle interface signal QSP turn counterclockwise, and it is activated by push button PB M04. Next rung is a logic to stop our spindle with output interface signal QSP stop and activated by push button PB M05. Next, we'll make a logic to select spindle for jogging. So, the same like we did for axis, we use standard function blocked IL toggle. We'll name it FB select S1 and let system auto-declare it. We'll be toggling our LT select S indication light using push button PB select S. Also, we want this selection to be active only in manual mode, so we'll use indicator LT manual to reset selection when we are not in manual mode. We'll also use built-in function to remove all unused inputs of our function block. Next rung is a logic to jog our spindle in positive direction. So we insert new coil, and it is spindle interface output QSP jog plus. It is activated by push button PB jog plus, but only when spindle is selected and light LT selected S is on. Next line is for spindle jog minus, and our output is spindle interface out signal QSP jog minus, controlled by push button PB jog minus and light LT selected S. Next, we'll create a logic to indicate spindle motion status. Our coil is a light LT M03, and it will indicate for us that spindle is in motion in clockwise direction. So we'll check here spindle interface in signal ISP turn command. That will tell us if spindle is commanded to run. And then to verify direction, we'll check another spindle interface signal ISP turn direction M4. This signal will be true when spindle runs counterclockwise, so in this rung we must negate it. Next rung is an indication that spindle is running counterclockwise. So our output is a light LTM04, and verification signals are the same, except direction signal is not negated. In the last rung, we'll verify if spindle is stopped. So our output is a light LTM05. We check if there is no active turn command, and check spindle interface signal ISP stop. Now our basic program for spindle is ready, but before we can test it, we must add it to task configuration. So we open PLC task, then add call, and then select our program prSpindle. Next, we build our program, and if there are no errors, we can download and test it. Same like in previous videos, to test our logic, we'll use IndraWorks Operation Simulator. And system, after download, starts for us in automatic mode with active automatic operator panel. We can see here slider for feed rate override, and in our first step we'll make a slider for spindle override. So we switch our panel to edit mode and then copy and paste a feed rate override slider. Next we edit this new slider. So here we replace FOVRD variable with SOVRD, change an icon, and to make sure that spindle will never be accidentally stopped with this override, we set a minimum to 45%. Next, we exit configuration, and we can see our spindle override logic and slider working properly. Next, we'll switch to manual mode to test other functions. So edit operator panel, and first just copy override slider from automatic panel. Next we'll add a button to select spindle for jogging. So first we copy and paste button for Z-axis selection and then edit it. So we change variables operated by this button, the text in button field, and button icon if used. Next, we add a button to start spindle clockwise, then a button to start spindle counterclockwise, and finally a button to stop a spindle. Next, we click Exit Configuration and we are ready to test it. Going back to our logic, first we will check a part responsible for spindle jogging and spindle status. We can see right away that spindle is stopped and not selected for jog. Next we'll call back our operation screen and first we'll select spindle for jogging. We can see our variable LT_SELECT_S set to true and active light on button S. Next we push button jog plus. We can see interface signal QSP jog plus activated and interface signals back from control. Set our light LTM03. Also please note icon change in NC screen window with programmed jogging speed at 100 RPM and commanded speed overridden to 91%. Next, we push jog minus, and again we can see icon change and active light LTM04. Next, we check a logic to run spindle in manual mode. So we click on button M03. That activates our interface signal QSP turn clockwise and starts our spindle. We can see icon change showing clockwise rotation, but programmed and command speed shows 0. Please note that when we start spindle in manual mode, it will run with last programmed speed. Jogging speed is not considered to be a programmed speed. We can program spindle speed direct in MDI mode or in our program in automatic mode. So let's switch to MDI mode. Here we can issue a command M03S1000 and that should start our spindle to run clockwise with speed 1000 RPM. Next we hit start and we can see spindle running programmed 1000 RPM and commanded 910 RPM. Next we will switch back to manual mode. When we click M04 button, spindle will reverse and run counterclockwise with the same speed. When we click M05 button, spindle will stop. We tested our logic using virtual spindle, and in the next step we replace it with a real one. So I will connect my test drive with circuit address 4 and edit NC configuration. Here I'll edit drive 4 and set parameter activate virtual mode to no. Next, for this change in parameters to take effect, system must be rebooted. After restart, we can see right away a new element in Project Explorer, and it is our drive number 4. When we click on Axis Mechanics and Scaling, we can see that it is configured as direct spindle with modular position format. When we click on Axis Diagnostics, we can check actual spindle status. We can see that there are no errors and drive is ready for power on. So in the next step, to power our spindle, we'll use already existing program PR Power and add to it a logic for spindle. So first, we'll check spindle interface signals ISP drive power and ISP drive ready, and if they are true, set spindle interface out signal QSP drive on to enable the drive. Next, we add a logic to check if spindle is powered, and then add the result to our power indicator light LT power on. Next, we compile and download. After download and restart, we can see logic running, simultaneously watch operator panel, and see our spindle drive. So first we'll push power on button. We can see spindle powered signal and power on light active. When we look into axis status, we can see drive in velocity control with status AF, drive with torque. When we look on front panel of our drive, we can also see status AF. So our drive is powered up, and before running a spindle, we'll set override to 100%. Next, we'll switch our control to MDI mode and issue a command M03S1000. Next, we'll push a start button, and we can see our spindle running clockwise with a speed of 1000 RPM. Next, we'll switch to manual mode. We can see our spindle still running, and we'll push M04 button. We can see our spindle reversing and running counterclockwise with the same speed of 1000 RPM. Next, we'll push M05 button and see our spindle stopped. Next, we'll test spindle jogging function. So we push S button to select spindle, then we can jog plus and jog minus. That was a last test of our video. Thank you for your attention.